Which of the following reactions would give this product? Let's take a look at A. When I see an alkene and an HBr, I immediately think of a hydrohalogenation reaction. This reaction has a few key components. It adds a halogen, so in this case a bromine, to the Markovnikov position. It also makes a carbocation, which is just a positive charge on carbon due to a lack of hydrogens on the atom. And because a carbocation is formed, this reaction allows for a rearrangement. Let's start off with defining what Markovnikov is. When a reaction gives the Markovnikov product, it means that the bromine goes onto the most substituted carbon. Let's look at this alkene reactant, for example. The bromine can either go to the tertiary carbon or the secondary carbon. However, we'll prefer the tertiary carbon because it is more substituted and the substituents around it stabilize the carbocation. On the other hand, if a reaction gives an anti-Markovnikov product, then the bromine will be on the least substituted carbon. So in this case, the bromine will be on the secondary carbon. And the one previous will put the bromine on the tertiary carbon. I also previously mentioned that there will be a carbocation. When a reaction has a carbocation intermediate, it means that the molecule can be rearranged. This means that the carbocation or the positive charge goes from a less substituted carbon to a more substituted carbon in a shift. We can see this in a curved arrow mechanism. The first step in any hydrohalogenation reaction is for the nucleophilic alkene to attack the very electrophilic HBr and take its hydrogen. The positive charge will end up on the Markovnikov carbon. This is what we call a hydride shift. Now the carbocation is on a more substituted and more stable tertiary carbon. Now we can attack the carbocation with the bromine ion from before to form this final product. Going to B, in the presence of peroxide, so in our case hydrogen peroxide, the anti-Markovnikov product will be favored. Since no carbocation is formed, there will be no rearrangement. We choose between a primary carbon and a secondary carbon, and of course the less substituted carbon will be the primary one. So this is our product. Knowing this, we can look at C, where we choose between a secondary and tertiary carbon. Because hydrogen peroxide is present, the bromine will end up on the secondary carbon, giving this product. Therefore, our answer is C.